All right, we're going to look at two problems from the homework light number 4. And the problems we're going to look at are numbers 5 and 9. Number 5 is about the photoelectric effect. And what we're looking for is the minimum energy needed to eject electrons with this given threshold frequency. And then if you shine light with this wavelength, what will the energy be? So this is the equation that we're using for the photoelectric effect. Kinetic energy of the outgoing electrons, energy of the photon, binding energy. Now, in that problem, they give you the threshold frequency. That allows you to find the binding energy because the threshold frequency will be the frequency that's required to just overcome the binding energy. So then the binding energy is Planck's constant times the threshold frequency. So multiply these two numbers together and you get 2.11 times 10 to the minus 19 joules. So that is going to be your binding energy. Let's go back here. So that's the minimum energy needed to eject the electrons. The binding energy is that. Then the next part, we want to find the kinetic energy of an electron when the incoming photon has a wavelength of 275. So we need the frequency. Frequency is speed over wavelength. And so we get the frequency is this number, 1.09 times 10 to the 15 hertz. And then we plug this into this formula here, now that we know what the binding energy is. So the kinetic energy is going to be h times frequency with this frequency, minus the binding energy, which we found in first part of the problem. And you get the kinetic energy is 5.11 times 10 to the minus 19 joules. Okay, so that is problem 5. Problem 9. For this one, we're figuring out the de Broglie wavelength for a bullet with that speed. Now, the only tricky part is you need to see that it is miles per hour, and so you need to convert that to meters per second. So I did that with Google. 1313 miles per hour is 587 meters per second. Then the equation we're using is the de Broglie relation. Wavelength is h over p. And so h is the constant, p is the momentum, mass times velocity. The mass is given, and it's given in grams, so you need to convert it to kilograms. That's why it's 10 to the minus 3. And then the speed that we found, 587. And you get an answer of 1.24 times 10 to the minus 34 meters for the wavelength.